So this is the Azure portal, right? And this is where you go to provision stuff on the cloud. And you can create storage accounts here. So it's blob storage. You can create virtual machines. You can create managed Kubernetes clusters, anything your heart desires. And if you wanted to get started, what you would do is go into the, where is AI and machine learning? And you would create something called a machine learning service workspace, right? And this encompasses everything you need in order to do ML. And this is probably going to take too long for me to do on the spot, but let's give it a chance. Let's see, IT camp space, yeah, just a subscription. I have a couple, but you're probably going to have just the one. And you're going to stick them in a resource group. And a resource group is just sort of a folder structure that allows you to logically group the stuff you create. If you create something and you leave it running, obviously it's going to cost you money. So the way I have had instances where I left, a conference presentation and I'd used up hundreds of euros of Azure credits. So in order to keep that from happening, I try to group everything into a specific resource group and delete it after I'm done. And you get to define which region you want this workspace to be provisioned in. And we're going to go with Northern Europe. I'm going to review. Yeah, it validates everything, and then we hit create. And it's going to go ahead and do its thing. But and this might take a few minutes. So just because I don't want us to sit around here and wait, I'm going to switch to one that I created beforehand. So in ITCAM 19, there is an SNML service. And let's see what we have in here. So we have compute, right? So when you're training your model, it needs to run on something. And these are just virtual machines, or rather sets of virtual machines, and I have two clusters, right? One is made up of, let's see, let's do an edit. One is made up of DS1_v2 virtual machines, and it lives in Western Europe, and it has a minimum of one node, so I want to keep at least one open because it does take a while for them to spin up. It will scale up as high as 3, and if they don't get any action for 120 seconds, it kills them, right? So I'm using 3, and then it goes back, and there's no, they go on idle, it kills 2 of them. And I can actually dynamically scale this thing out. And I'm going to go 5, and it's going to start doing its thing. But currently, there's no running work on them, so there's just the one, and it's currently idle. And I also have, for example, another one, which is an extra large one, which I created more recently. Again, it's and this one is using bigger virtual machines. These are D13s that have, I think, 4 or 6 cores and like 50 gigabytes of RAM. So these are larger virtual machines. Oh, and it actually finished provisioning my other workspace. Now, another item of interest here is the virtual interface. As I said, my Python skills suck, so I'm not going to go in there, but I'm going to use the UI. And has anybody ever here seen Azure ML Studio? Okay, so a few folks. Now, what this guy allows you to do is to create and train machine learning models just by using a visual interface, and it's really powerful. Now, this technically is something different. It's the machine learning service, and the studio is going to get deprecated, but they're still really, really similar. So what I have in here is something I created a couple of a while ago, and I'm not going to, just because a few folks have seen it, I'm not going to recreate it from scratch. But this is very similar to SQL Server integration services, for example, or any sort of ETL package, ETL tool that you might have used, right? So I have an input, which is just a CSV file, and I think I can actually download it and show it to you, right? So this is just, and it's one of the samples you've seen here, right? So I've been doing demos with this thing for 4 years now. So this thing came out in 2014 or 2015. So this is just an extract from the US Census, and it has, people's age, their working class, their level of education, their marital status, their occupation, race, gender, how many hours per week they work. native country, right? So their country of origin and their income. And their income is sort of a binary classification. So people either make less than or equal to $50,000 a year or more than $50,000 a year, right? So I'm sure quite a few of you have seen this. The other really popular one is the Titanic data set, which has all of the list of all of the passengers on the Titanic and whether they made it or not. And a really popular one is to try to figure out if you had been on the Titanic, would you have survived or not based on your characteristics, right? And what this allows you to do is obviously some sort of data manipulation, right? So in this particular case, what I'm doing is, hold on, edit. What I'm doing here is I am removing my redundant columns. So columns that I don't need, I'm just throwing away. And then I'm going to split my data, right? So I'm going to keep 70% of my data to train my model, and then I'm going to evaluate it with 30%. And that just means that, out of 100 records, 70% are going to go flow through here, 30 are going to flow through here. I have a machine learning algorithm, right? A two-class boosted decision tree, which has a bunch of parameters, right? So these are called hyperparameters because you have to specify them ahead of training. And I'm with my 70% of the data, with this algorithm, I'm training a model, I am then scoring it, right? So I'm comparing, I've got the guess from my model and the actual correct value on the data set. And this, I actually ran this guy ahead of time, and I could actually see the results. And right, so it ran on 9,768 rows, and this is the value in the input file, and this is what my machine learning model guessed. And for the most part, you see that it did a pretty good job. Let's see, oh, it made a mistake on this one, right? So this Irish guy, it said that he or she's gonna make less than 50,000, and the guy actually makes more than 50,000, right? But you don't have to go in and compare line by line. We have a really nifty evaluate model component, which just gives you a nice visual representation of the accuracy, right? So the left-hand model had an accuracy of 0.84, right? And accuracy is just, I forget what it is, true positives plus false negatives divided by, I don't remember the formula, right? But there's a few metrics out there that you can use to identify the accuracy of a model. In this case, it guessed correctly, let's say 84% of the time. Something that is above 90% would be extremely good. If you've got above 95%, something's probably wrong because you're overfitting your model, but that's a whole different discussion there. And what I did here is I have one algorithm here, a two-class boosted decision tree, and a two-class average perceptron. The perceptron is one of the oldest algorithms out there. I think it was developed in the 70s, and this visual interface has a nice way of comparing them. So obviously, as you can see through this visual representation as well, the left-hand one did much better than the right-hand one. This one has an accuracy of under 80%, right? So 0.795. Now this is how you would do it manually, right? It's a sort of like a soccer competition, right? The guy that won the last match stays on the field. You bring in a new one, they duke it out. This one goes out, bring in a new one. Maybe you switch the maximum number of iterations. Maybe you specify a different value for the other one, and you go around and around and around until you find one that's suitably accurate, right? That is obviously very time-consuming. So where the interesting stuff happens is here. Automated machine learning. So what this allows you to do is, and it's done. I actually started one before we started. We will create an experiment, and we will pick awesome demo one, I believe is the one. I will pick the big compute cluster. So it goes quickly. It will look through my blob storage accounts. It will find the fact that I uploaded the CSV that I showed you guys a few minutes ago, and it allows me to pick which columns I want to feed in there. So age stays, working class stays. This one I don't need. Education, no. The occupation, yes. Race, unfortunately, is relevant. Gender is relevant, unfortunately, again. These are not relevant. Hours per week, yeah, they're probably going to have an impact on your income. Native country as well, and income is going to be included. I need to tell it what sort of prediction task I'm telling it to do, right? So the fact that it is a classification problem. So I need it to tell me if people make more or less than. So this is the simplest thing you can do, binary classification. You have just two buckets. And then the target column is obviously income. Although you could do it the other way around, based on people's income, try to guess their age, right? Which will be a more multiple class classification problem at that point. And to the gentleman that asked me about algorithms, you can't really give it additional ones. Oh, and the primary, the metric is in here, right? So I wanted to pick the winner to rank them based on the accuracy. I wanted to work for 60 minutes. Maximum number of iterations 25. The threshold, right? If it reaches an accuracy above a particular threshold, it can stop. Bunch of other stuff. And I can't give it my own custom algorithm yet, but I can blacklist some. So for example, if I'm really sure that, I don't know, gradient boosting isn't really applicable, check it and it won't try it at all, right? So that will sort of reduce the number of algorithms it'll try so that it spends more time working on the ones that are really relevant. So I hit start and it's going to start doing its thing eventually. Right. I started one, oh crap, 90 minutes ago, and I think 90 minutes have passed, so it's finished. I wanted to have one that was in the middle of doing its thing. Because this has a bit of ramp up time. It's going into a preparing state. Right, so this is the one that I started at 2:49 p.m. and it's 3:50. Oh, I guess it's finished earlier. So it's going to go into preparing state. But what? Let me show you a completed one. Right. So this is the one that finished. And this is just a visual representation of the accuracy results of all of the algorithms that are tried across a bunch of different iterations. And the most successful one is this one, 0.8453 blah, blah, blah accuracy, which is pretty good. And it is something called a voting ensemble. Right? So voting ensemble is the one I was struggling to describe earlier, where it picks several algorithms and it lets them vote. And essentially, it's a majority rule type setup, right, where it's relying sort of on the wisdom of the masses to produce slightly better accuracy than just relying on one. And you can see the lowest one it produced was around 71%, which is pretty bad. But then it slowly got to where it's pretty good, and I can see the accuracy here. So this is the leaderboard. It took it 1 minute and 26 seconds to actually train and evaluate this guy, and actually I can grab my model, which, as I said, is a pickle file, which is a Java, which is a serialized Python artifact, and I can take it and I can either deploy it within some Azure compute, or I can take it and run it on premises. I can do whatever I want with it. And if we go back to the one we just started, oh, it's still preparing. But if you look at the compute, for example, it should. So I think I told it to run on the XL cluster. It is. So one of them is running, and as it picks up steam, you'll see it, spin up. This cluster is going to go into, I think they refer to it as a scaling state, where it's spinning up to additional nodes, and it's going to start running experiments on that one as well. On the new ones as well. So it's really fun to follow along and see how it does through the telemetry mechanism. Yes? Yes, yeah, so they have GPU instances, GPU optimized instances, and I think FPGAs as well. So yes, I mean, let me show you actually. I go to add compute, I give it some cluster and compute type. Obviously I can pick any something other than machine learning compute, but let's go with this, Western Europe, and I'm going to choose a machine learning size, and this is the whole list of sort of the machine, the VM types that are supported. And if we go to Azure ML service pricing, I think this page has a nice table of There we go. So you've got general purposes, compute optimized, memory optimized, storage optimized, GPU, because I don't know them by heart, right? So the NC ones are apparently GPU optimized ones. So yes, it does support that. And you have FPGAs here as well, which are free. Awesome. So there you go. Yeah, it's in preview, so it's free. So knock yourself out. So I'm sorry, no second box of candy for you. And for example, if this one ran already by, for example, I can tell it to, there you go, come on, run on the other cluster. And this is the nice thing about the ML service as opposed to the ML Studio. When it came to the ML Studio, your compute ran on some sort of compute layer that you didn't really understand. It was a black box. In this case, your experiments here run on compute that you manage, and you can scale out or scale back in to your heart's content. And if we go back to, let's see if the experiment, how the experiment is doing. Automated machine learning. Boom, boom, boom. Oh, and it's running, so we can see it in real time. And it's done a couple of them, right? So it's the best one we have right now is 0.83. So it's still already pretty good. So the one we built by hand was 80 some plus change. So it's getting pretty good. And as it, so you're seeing it, right? So it tried a couple of things, and it's going to keep going and keep going. This guy is going to keep updating. Let's refresh it here by on demand. Oh, it's no, still that one. It found one that's worse. But yeah, every couple of minutes it's going to populate with more experiment results, and it's going to go, keep at it for quite a while. Okay. Questions so far? Oh, excellent. Quite a few. Yes. No, not really. I mean, it's well, it depends, right? So I'm not a true data scientist. I know enough about it to be dangerous. So if you're a real practitioner, maybe it has taught me stuff, right? I didn't know about voting ensembles until I saw it produce one as the winning algorithm, and I was like, what the heck is that? And I had to go out and read it. So I have learned stuff from it, but not at a level of, given this data set, my gut feeling is, the average perceptron is going to kick ass, but it's actually a boosted decision tree. So I'm not that good of a data scientist, unfortunately, and my gut feeling sucks. That's why I need stuff like this. That's why we need stuff like this. But yeah, good question. And I saw a few more at the back. Yes? How does it compare with other tools? There's a slide on that, so I'm going to show you. So there's a few. Microsoft doesn't have a monopoly in this space. In sort of this, in the machine learning industry, there's a lot of, what they say, imitation is the most sincere form of admiration. So everybody admires the hell out of everybody else, right? So there's a lot of competing frameworks out there. And Microsoft, well, I'll show you the Gartner chart and everything. So there's information about the competitive space here as well. Yeah. So the question is around retraining the model, right? So going back to the process where I showed where you have to go back and then retrain it based on new data, based on new learnings. Not currently. So what's funny is, but you can very safely anticipate that is going to be added in. For example, when Microsoft came out with ML Studio in 2014 or 2015, it didn't have that capability. And then I think 1 or 2 years later, they added it in where you could programmatically retrain your model based on a new data set. So you can safely assume that they're going to add this into the product, but it doesn't currently support that. You have to go back in and kick off AutoML all over again. But it's not that painful. You can sort of automate it yourself by keeping at it. You can sort of automate it itself, but you'd have to write your own sort of scripts and use the Python SDK to do that. But the visual side of it doesn't really have that yet. If we go back to the compute, let's see what they're doing. So compute, the clusters are, okay, let's see. Oh, so there you go. So it is already, right, so it's running on 2 nodes already, and it's preparing a 3rd one. So you can see that, the scaling mechanism works. Yes, any other questions? Okay, back there. It does that on its own, actually. So it's smart enough to do a certain level of that. It is smart enough for the example I gave you earlier. For example, if there's a high cardinality on a feature, it will drop it on its own. It's smart enough to produce, under certain conditions, synthetic features. It's smart enough to figure out, oh, so if you, it looks like you're trying to give me a datetime, and it's smart enough to figure that out if you're trying to do time-based regressions. So to a certain extent, yes, but you can't really influence that side of it. So if you want to do some of that, you're probably better off just doing that ahead of time and giving it the CSV with the features you'd want to be interested in. So sort of is the answer to that question. Yes, and I think I saw another hand go. Yes. You can tell it when to stop, right? So, oh, I found one that's in this level of accuracy. Okay, I'm done. Well, that's up to you to decide, right? If your training data is not diverse enough, you're going to get that anyway, right? So that's sort of your job. Oh crap! It's 99% accurate. That's probably not good. Yeah, there's no upper bound really. That's for better or worse. No, I don't know. That's not a limit. Oh, and what would it do with it anyway, right? You wouldn't want it to stop if it finds something that's 98% accurate. It would show up in there in the leaderboard, and you would say, okay, so this one's probably not a good fit because it's probably subject to overfitting. So I'm not going to use this one. I'm going to use the one that's 90% accurate. So it's going to show you that data anyway. Yes. Oh, interesting. So the question is if it. I would guess that you're going to get the same result. I have no idea. Right, so between different runs, it might vary slightly because there's randomness to how it does the split, which row goes into training, which row goes into evaluation. I haven't really tested that. Well, I've never really run an experiment with the exact same inputs to see if it picks up the exact same level of accuracy and the exact same algorithm. I'll have to try, so I have no idea. That's a good question though. Yeah, and all the way in the back. So the question is, if I add new data, you're going to have to retrain it all over again. So it doesn't really do any sort of reinforcement learning where so I've got it, and then I'm enhancing it with just a delta of data set. No, you have to start from scratch every single time. But that's not a limitation of this framework. That's just a limitation of you have to retrain from scratch. And your candy, I'm putting it to the side because I don't want to walk all the way back there. And okay. And okay, so there you go. So all three of my cluster nodes are added. So now I've got like 24. What's it now? It was 6 times 3, 18 CPUs and or rather cores and like 150 gigabytes of RAM working on it. And let's see what the results are looking at like right now. So it's running, and okay, and we're 841, which is pretty good. Let's see, the one I trained myself. Let's see. It would be really funny if my really simple example here beat it out. So let's see. And oh, okay, 84.7. So I'm still in the lead, which is surprising. Okay, let's see how this one did. So this is something. Visualize. So this one is at. So the left-hand one is 840. Okay, interesting. So what did I use here? This was logistic regression. There you go. So logistic regression does a really good job on this one.